Hello students. Today we are going to learn about exponents and how to apply the property of exponents. We will start first with the definition. The definition of an exponent is the number that indicates how many times the base is used as a factor. For example, on 2 to the third, it equals 2 times 2 times 2, which equals 8. So we can write that in. What number is the base? The big number, or 2. What number is the exponent? The smaller number. In this example, it's 3. So if we have a times a times a, that would equal what? A to the third, because we multiplied a 3 times, and that is what the exponent is 3, the base is a. So that's just going back to your basics of what an exponent is and what it means. So here we're going to have some examples, and we're also going to multiply some exponents. So we have 4 times 4 times 4, which is 4 to the third. And I forgot to save this, so. Okay, so then we have 2 times 2. So in this parenthesis, we have 2 to the second power. And this one is 2 times 2 times 2. And I guess that is 2 to the third power. Okay, no, that was right. 2 squared, because this one matches up with this one. And this one is going to match up with this one. 2 to the third. Now, when you just have the bases the same, multiplied, no other things you can add. 2 plus 3 is 2 to the fifth. And then if we wanted a number answer, we would go 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is, and the answer would be 32. This is if we want to evaluate. So if you evaluate, you get a number answer. If they say rewrite using exponents, then you would want this one right here. Okay? So if we rewrite this using exponents, 5 to the 10th times 5 squared, again, that's all you would do unless they said evaluate. Well, actually, you would add the exponents 5 to the 12th. That's rewrite using exponents. And then if you were going to get a number answer, you would go 5 to the, on the calculator, you would go 5 y to the x, if you have my type of calculator, 12 equals, and then that would get you your number answer. Okay? All right, we're going to go on to the next one. And these are just examples that I made up. They're not from your homework or on any notes or anything, but you might want to write these examples down. So if we have x as a base here, x to the fourth times x to the eighth, since it's multiplication, we add the exponents, x to the 12th, and we have that. Now, here's a mix of both variables, which is your letters, and numbers, which is your coefficient. The coefficient means it's a number in front of the variable. So we go 5 times 6 is 30. We multiply the number in front. Now when we have the bases the same, x's are the same, we can add the exponents. 3 plus 8 is 11. And then y to the fourth, y. If y is by itself, we should put a 1 there, so we remember we're going to add 1. Too many times students don't do that. So we go 4 plus 1, and that's y to the fifth. And so, again, multiplication. I'll show you also some steps for multiplication in the next one. You want to multiply the numbers in front, mark the like terms, combine the like variables, and you add their exponents. So for this example right here, and again, you may want to stop the video so you can write some of this stuff down. Okay, so multiplying with exponents. As a multiplication problem, there's no adding and subtracting. This subtraction right here, this is a negative sign. So you multiply the numbers in front. 4 times negative 3, negative 12. Then we're going to mark like terms. I'm going to box this one. And I see, because the x's are the same, I can add the exponents, x to the 7th. And then, if there's nothing there, I want to put a 1 there. And I'm going to circle them. Y's are the same. We go 4 plus 1 is 5. So y to the 5th. And you have your answer there. Now, why don't you go ahead and try this next one to see if you can do it. You can stop the video because I'm going to keep going. Now, when nothing's in front of the variable, it's like a 1. So we multiply the first one. 3 times 1 is 3. Then I'm going to mark the like terms. There's the A's. And then the B's. I'm going to circle. Oh, there's no B's over there. And so what should C do? What should I do with C? Let's see. I'll try and make it a triangle. Okay. A, 1A to the first, A to the second. I add the exponent, so that's A to the third. B, there's only one B, so I put B squared. And there's C, we just put that C to the 5th. And there's your answer on that one. Okay? And it's not like a 3A plus B squared or A squared C to the 5th. That's what it is not. Okay? And if you need more time, again, pause the video. I'm going to continue on with division. You divide the numbers in front and subtract the exponents that have the same variables. So if I divide 8 divided by 4 in the beginning, I'm going to get 2. So this equals 2. And I subtract the exponents on the x. 4 minus 2x squared. This one, I divide this in front. If anything, I can also split it up like that. And I divide on the left, and I subtract exponents on the right. So 9 divided by 3 is 3. And 8 minus 1, a to the 7th. Okay, now it gets a little bit more tricky. 4 to the 3x over 4 to the 2x. All I can do is I can go 4 to the 3x minus 2x. And what does that equal? Because over here I could have done 3a to the 8 minus 1, and I got 7 there. So this would be 4, 3x minus 2x is just 1x, and I just put it as x. I could also put 4 to the 1x, but usually you don't put the 1 in front. Okay, now this is even trickier with more distance here. So we go 5 to the 2x minus 1 minus, I have to minus everything down here, x plus 3. Okay, so then I get 5 to the 2x minus 1 minus x minus 3. Okay, and then I combine like terms, and that equals 5. 2x minus x is x, and then minus 1 minus 3 is minus 4. So we're following the concept of if it's division, we subtract the exponents when you have the same base. And, oh, I need to go 5. This time, we don't divide 5 divided by 5 because that's our base. We keep 5 the same, which is kind of different from all of these, but this 8 and this 4 did not have exponents. So these do, and so they stay because they are your base. Base equals 5. Here, the 8 and the 4 is not a base because there's no exponents with it. 9 and 3, not a base. 4 over here is a base because it's the one with the exponents. So hopefully that's not too confusing for you. I will do some more examples on the next page. Okay. This one, when you have parentheses and it's raised to a power, first we're going to go 5 squared. We're going to go ahead and say that's 25, x to the 4th, all raised to the 3rd power. So even though 25 doesn't have a power, I'm going to put 1 there. So that equals 25 to the 3rd, and then we go 4 times 3 is x to the 12th. We could also write that as, or it could be 5 to the 2 times 3, 6th power, x to the 12th, or it could also be the number power. And I don't have a calculator on hand. Well, I have one on hand, but you could figure out what that number is and then put x to the 12th. Now for this one here, I'm going to take the exponents, and when there's no exponent, I'm going to put a 1 there, and I'm going to multiply it by -2, all of these exponents. So 2 times -2 is -4. 4 times -2, that's -8. B is 1 times -2 is -2. Now, you never leave exponents negative. So to make them positive, what I call shove them in the basement, like naughty children. I probably shouldn't say that, but you put them downstairs in your fraction. So these are all upstairs. We're going to put them downstairs, and they become positive. 3 to the 4th, a to the 8th, b squared. And if nothing is upstairs, we leave that 1. Sometime, or on the numerator. So that could be your final answer, or if you have to simplify it, 3 times 3 is 9, times 3 is 27, times 3 is, it could be 1 over 81, a to the 8th, b squared. And make sure you extend that over there. And there's your final answer on that one. So let's go ahead and do some homework problems here that we have. So number 5, first you ask yourself what kind of problem it is. When you have parentheses on the outside and a -3 on the outside, you multiply. 5 to the -12. We never leave exponents with a negative, so we have to shove them in the basement. So this is going to have to be 5 to the 12th, and we leave a 1 on top because there's nothing there. Okay? And going back up to this one, I probably should have written it out that this is 5 squared x to the 4th times 5 squared x to the 4th times 5 squared x to the 4th. So that's what that 3 means, is we're taking this whole thing and multiplying it by itself 3 times. So if we have 5 squared, so we can go plus, 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 and that's where you get your 5 to the 6th. We can add 4 plus 4 plus 4. That gets you x to the 12th. So you can see multiplication is just a faster way to do addition, just like when you learned how to add first in grade school and then multiply. All right, now we're going to go on to number 7. And this is outside the parentheses, so we have to multiply the exponents. So we go -6 times 2, and we're going to do our multiplication first and simplification after. That equals 8, keep the base the same, -12x plus, or I could just put minus, I think I'll change that to minus 42. And I think I would just, the exponent is negative and we don't want to keep it like that. So equals 1 over, we're going to make both of these positive, 8 to the 12x plus 42. That way it's all positive, and there's your answer. Okay, let's go on to number 9 over here. Since it's multiplication, we're going to, the base, there's no parentheses, we're going to add the exponents since this is the same. So it's 7 to the 4a plus 6 minus 4a. So when you combine like terms, this 4a and minus 4a added together, they equal 0. So they go away. So we're left with 7 to the 6th power. And if you wanted to do that on the calculator, again, it would be 7. You could use that if your calculator has that. 6th or 7y to the x. 6 equals, and whatever your calculator gives you for that. Okay, now we'll go on to number 16. And since it's division, we're going to subtract. The base is the same. So we go 9. That's the base on both of them, so we don't divide that one. And we go x plus 6 minus 3x minus 9. Okay, we're going to distribute the negative through parentheses and get -3x plus 9 I'm going to cross that out now. Combine like terms. There's a 3x, a negative 3x, and an x. So we get 9 to the negative 2x, 6 and 9 plus 15. Okay. I'm going to go ahead and leave it like that. I'm trying to think if we still shove it in the basement because this is negative and this is not. So it could also be this, 9 to the 2x minus 15. So I will accept either of those answers right there. Okay. Now, your homework right here is to do 4.1 property of exponents, the front and the back page, 20 problems. Have fun, students.